My dear students, hello. I welcome you all in our series of lectures on cybersecurity. Today, we are going to study about computer network basics. In this lecture, we will learn about various network types and topologies. We will also learn how to identify basic topologies and their variations and how to determine appropriate topology for a given network plan. So, let us begin with it. A network is a set of devices often referred to as nodes connected by communication links. A node can be a computer, printer or any other device capable of sending and receiving data generated by other nodes on the network. Most networks use distributed processing, in which a task is divided among multiple computers. Instead of one single large machine being responsible for all aspects of a process, separate computers, usually personal computers or workstations, handle a subject. A network must be able to meet a certain number of criteria. The most important of these are: number 1, performance, consistency, reliability, recovery and security. Let us study all the criteria one by one. Number 1, performance. Performance is defined as the rate of transferring error-free data. Performance can be measured in terms of transit time and response time. Transit time is the amount of time required for a message to travel from one device to another. Response time is the elapsed time between an inquiry and a response. The performance of a network depends on a number of factors, including the number of users, the type of transmission medium, the capabilities of the connected hardware and the efficiency of the software. Performance is often evaluated by two networking metrics such as: number 1, throughput. Throughput is the number of messages successfully delivered per unit time. Throughput is controlled by available bandwidth as well as the available signal to noise ratio and hardware limitations. The throughput is calculated by dividing the file size by the time to get the throughput in megabits, kilobits or bits per second. Number 2, delay. Network delay is an important design and performance characteristic of a computer network or telecommunications network. The delay of a network specifies how long it takes for a bit of data to travel across the network from one node or endpoint to another. It is typically measured in multiples or fractions of seconds. Network delay is divided into several parts such as: processing delay. Processing delay is the time routers take to process the packet header. Number 2, queuing delay. It is the time the packet spends in routing queues. Transmission delay. It is the time it takes to push the packet's bits onto the link. And the propagation delay. Propagation delay is the time for a signal to reach its destination. We often need more throughputs and less delay. However, these two criteria are often contradictory. If we try to send more data to the network, we may increase throughput, but we increase the delay because of traffic congestion in the network. Number 2, consistency. Consistency is the predictability of response time and accuracy of data. Users prefer to have consistent response times. They develop a feel for normal operating conditions. For example, if the normal response time is 3 seconds for printing to a network printer and a response time of over 30 seconds happens, we know that there is a problem in the system. Accuracy of data determines if the network is reliable. If a system loses data, then the users will not have confidence in the information and will often not use the system. Number 3, reliability. The reliability of the network is measured by certain factors such as frequency of failure. Frequency of failure determines how frequently the network fails. Recovery time. It is the time taken by a device or network to recover from the failure. Catastrophe. Network must be protected from the disasters such as fire and earthquake. Number 4, recovery. Recovery is the network's ability to return to a prescribed level of operation after a network failure. This level is where the amount of lost data is non-existent or at a minimum. Recovery is based on having backup files. Number 5, security. Security of the network is considered as the most important aspect for improving the network performance. The network security may be affected due to viruses and unauthorized access of other users. To provide network security, avoid opening unknown email attachments which may contain virus. Use antivirus software for securing the systems from virus. Firewalls can be implemented for detecting and preventing unauthorized access of other users in the network. Use backup tools to store the important data on removable media like CD or zip disks. This helps to secure your data. Turn off the system and remove the network cable when not in use to avoid unauthorized interference in the systems. Now let us learn about physical structure of a network. Physical structure of a network is described by type of connection and topology of network. So what do you mean by type of connection? A network is two or more devices connected through links. A link is a communications pathway that transfers data from one device to another. For visualization purposes, it is simplest to imagine any link as a line drawn between 2 points. For communication to occur, two devices must be connected in some way to the same link at the same time. There are two possible types of connections, point to point and multi-point. A point to point connection provides a dedicated link between two devices. The entire capacity of the link is reserved for transmission between these two devices. Most point to point connections use an actual length of wire or cable to connect the two ends, but other options such as microwave or satellite links are also possible. When you change television channels by infrared remote control, you are establishing a point to point connection between the remote control and the television's control system. The examples for pure point to point links can be two computers communicating via modems, a mainframe terminal communicating with a front end processor, or a workstation communicating along a parallel cable to a printer. The other type of connection is multi-point connection. A multi-point, also called multi-drop connection, is one in which more than two specific devices share a single link. In a multi-point environment, the capacity of the channel is shared either spatially or temporally. If several devices can use the same link simultaneously, it is a spatially shared connection. If users must take turns, it is a time shared connection. The figure shows both the point to point and multi-point connections. Now let us discuss about topology of a network. Network topology is the arrangement of the various elements like links, nodes, etc. of a computer network. Essentially, it is the topological structure of a network and may be depicted physically or logically. Physical topology is the placement of the various components of a network, including device location and cable installation. The cabling layout used to link devices is the physical topology of the network. This refers to the layout of cabling, the locations of nodes, and the interconnections between the nodes and the cabling. The physical topology of a network is determined by the capabilities of the network access devices and media, the level of control or fault tolerance desired, and the cost associated with cabling or telecommunication circuits. Logical topology illustrates how data flows within a network, regardless of its physical design. Distances between nodes, physical interconnections, transmission rates, or signal types may differ between two networks, yet their topologies may be identical. there are 4 basic topologies possible: mesh, star, bus and ring, as shown in the figure. Let us discuss them one by one. Number 1, mesh topology. In a mesh network topology, each of the network node, computer and other devices are interconnected with one another. Every node not only sends its own signals but also relays data from other nodes. In fact, a true mesh topology is the one where every node is connected to every other node in the network. This type of topology is very expensive as there are many redundant connections. Thus, it is not mostly used in computer networks. It is commonly used in wireless networks. Flooding or routing technique is used in mesh topology. Mesh topology is shown in the figure and it is of two types. Number 1, fully connected mesh topology. In fully connected mesh topology, every device has a dedicated point-to-point link to every other device. The term dedicated means that the link carries traffic only between the two devices it connects. To find the number of physical links in a fully connected mesh network with n nodes, we first consider that each node must be connected to every other node. Node 1 must be connected to n-1 nodes, node 2 must be connected to n-1 nodes, and finally node n must be connected to n-1 nodes. So, we need n into n-1 physical links. However, if each physical link allows a communication in both directions, we can divide the number of links by 2. In other words, we can say that in a mesh topology, we need n into n-1 divided by 2 duplex mode links. To accommodate that many links, every device on the network must have n-1 input output ports to be connected to other n-1 stations. Full mesh topology is used only for backbone networks. Number 2, partial mesh topology. This is far more practical as compared to full mesh topology. Here some of the systems are connected in similar fashion as in mesh topology, while rest of the systems are only connected to one or two devices. It can be said that in partial mesh, the workstations are indirectly connected to other devices. This one is less costly and also reduces redundancy. Now, coming on to the advantages of mesh topology. There are many advantages associated with this topology, such as: number 1, data can be transmitted from different devices simultaneously. This topology can withstand high traffic. Number 2, even if one of the components fails, there is always an alternative present, so data transfer does not get affected. Number 3, expansion and modification in topology can be done without disrupting other nodes. Now, disadvantages of mesh topology. Some of the disadvantages are: number 1, there are high chances of redundancy in many of the network connections. Number 2, overall cost of this network is way too high as compared to other network topologies. Number 3, setup and maintenance of this topology is very difficult, even administration of the network is tough. Then comes star topology. In star topology, all the components of network are connected to the central device called hub, which may be a hub, a router or a switch. Unlike bus topology, where nodes were connected to central cable, here all the workstations are connected to central device with a point-to-point connection. So, it can be said that every computer is indirectly connected to every other node by the help of the hub. All the data on the star topology passes through the central device before reaching the intended destination. Hub act as a junction to connect different nodes present in star network, and at the same time it manages and controls whole of the network. Depending on which central device is used, hub can act as a repeater or a signal booster. Central device can also communicate with other hubs of different networks. Unshielded twisted pair Ethernet cable is used to connect workstations to central node. The central hubs also can be classified in the subtypes such as number 1, passive hub. A passive hub is a simple signal splitter. Its main function is to connect the arms of the star while maintaining the proper electrical characteristics. A passive hub routes all traffic to all nodes. This means that a tremendous load can be created when much communication takes place between computers. Every computer has the additional burden of reading the address of each piece of information it receives to determine if the information is intended for that computer. Information containing addresses of others is discarded. Number 2, active hub. An active hub performs the same function as a passive hub, but contains electronic circuits that regenerate and retransmit the information. Thus, active hubs can be used to extend the size of a network. Number 3, intelligent hub. Intelligent hubs perform the same functions as passive and active hubs. However, they can make informed path selections and perform some network management. Intelligent hubs route traffic only to the branch of the star on which the receiving node is located. If redundant paths exist, an intelligent hub can route information around normally used paths when cable problems occur. Routers, bridges and switches are examples of hub devices that can route transmissions intelligently. Intelligent hubs also can incorporate diagnostic features that make it easier to troubleshoot network problems. Figure shows the star topology. Now, the advantages of star topology. Number 1, as compared to bus topology, it gives far much better performance. Signals do not necessarily get transmitted to all the workstations. A sent signal reaches the intended destination after passing through no more than 3-4 devices and 2 to 3 links. Performance of the network is dependent on the capacity of the central hub. Second advantage is it is easy to connect new nodes or devices. In star topology, new nodes can be added easily without affecting rest of the network. Similarly, components can also be removed easily. Number 3, centralized management. It helps in the monitoring of the network. Number 4, failure of one node or link does not affect the rest of the network. At the same time, it is easy to detect the failure and troubleshoot it. Next is disadvantages of star topology. Number 1, too much dependency on central device has its own drawbacks. If it fails, whole network goes down. Number 2, the use of hub, a router or a switch as central device increases the overall cost of the network. Number 3, performance and as well as number of the nodes which can be added in such topology is dependent on capacity of the central device. Now, the next topology we are going to learn is the bus topology. Bus topology is the simplest of network topologies. In this type of topology, all the nodes, bus topology is the simplest of network topologies. In this type of topology, all the node computers as well as servers are connected to the single cable called bus with the help of the interface connectors. This central cable is the backbone of the network and is known as a bus. Every workstation communicates with the other device through this bus. A signal from the source is broadcasted and it travels to all workstations connected to the bus cable. Although the message is broadcasted, but only the intended recipient whose MAC address or IP address matches accepts it. If the MAC or IP address of machine does not match with the intended address, machine discards the signal. A terminator is added at ends of the central cable to prevent bouncing of signals. A barrel connector can be used to extend it. Figure shows the bus topology. Now, what are the advantages of linear bus topology? Number 1, it is easy to set up and extend bus network. Number 2, cable length required for this topology is the least compared to other networks. Number 3, bus topology cost very less. And number 4, linear bus network is mostly used in small networks, good for LAN. We also have certain disadvantages of linear bus topology. First disadvantage is there is a limit on central cable length and number of nodes that can be connected. Number 2, dependency on central cable in this topology has its disadvantages. If the main cable encounters some problem, whole network breaks down. Number 3, proper termination is required to dump signals. Use of terminators is must. Number 4, it is difficult to detect and troubleshoot fault at individual station. Number 5, maintenance cost can get higher with time. Number 6, efficiency of bus network reduces as the number of devices connected to it increases. Number 7, it is not suitable for networks with heavy traffic. And number 8, security is very low because all the computers receive the sent signal from the source. Next topology we are going to discuss is ring topology. In ring topology, all the nodes are connected to each other in such a way that they make a closed loop. Each workstation is connected to other two components on either side and it communicates with these two adjacent neighbors. Data travels around the network in one direction. Sending and receiving of data takes place with the help of a token. Now, what is a token and how it is passed? Token contains a piece of information which along with data is sent by the source computer. This token then passes to the next node which checks if the signal is intended to it. If yes, it receives it and passes the empty token into the network. Otherwise, it passes the token along with the data to the next node. This process continues until the signal reaches its intended destination. The nodes with tokens are the ones only allowed to send the data. Other nodes have to wait for an empty token to reach them. This network is usually found in offices, schools and small buildings. There are many advantages of ring topology. Number 1, this type of network topology is very organized. Each node gets to send the data when it receives an empty token. This helps to reduce chances of collision. Also in ring topology, all the traffic flows in only one direction at very high speed. Second advantage is even when the load on the network increases, its performance is better than that of the bus topology. Number 3, there is no need for network server to control the connectivity between workstations. Number 4, additional components do not affect the performance of the network. And number 5, each computer has equal access to the resources. There are also some disadvantages of ring topology, such as number 1, each packet of data must pass through all the computers between source and destination. This makes it slower than star topology. Number 2, if one workstation or port goes down, the entire network gets affected. Number 3, network is highly dependent on the wire which connects different components. And number 4, MAUs and network cards are expensive as compared to the Ethernet cards and hubs. Next is the tree topology. Tree topology integrates the characteristics of star and bus topology. Earlier we saw how in physical star network topology, computers are connected with each other through central hub. And we also saw in bus topology, workstation devices are connected by the common cable called bus. After understanding these two network configurations, we can understand tree topology better. In tree topology, the number of star networks are connected using the bus. This main cable seems like a main stem of a tree and other star networks as the branches. It is also called expanded star topology. Ethernet protocol is commonly used in this type of topology. The figure shows the tree topology. There are many advantages of tree topology. Number 1, it is an extension of star and bus topologies. So, in networks where these topologies can't be implemented individually for reasons related to scalability, tree topology is the best alternative. Number 2, expansion of network is possible and easy. Number 3, the whole network can be divided into segments which can be easily managed and maintained. Number 4, error detection and correction is easy. Number 5, each segment is provided with a dedicated point-to-point wiring to the central hub. And number 6, if one segment is damaged, other segments are not affected. Tree topology also has some disadvantages such as: number 1, because of its basic structure, tree topology relies heavily on the main bus cable. If it breaks, whole network is crippled. Number 2, as more and more nodes and segments are added, the maintenance becomes difficult. Number 3, scalability of the network depends on the type of the cable used. So, with this, our today's lecture is over. Today, we have discussed about various network types and topologies and the advantages and disadvantages associated with them. I hope you have understood the concepts. In the next lecture, we will discuss about various types of transmission media. Thank you. Have a good day.